This is a deep dive podcast covering articles published on Ecogate's blog, brought to you by Ecogate, the leader in intelligent industrial
Dust
ventilation.
collection, it runs all day. Burning white, blowing cash away. Dust collection, dust settles in the main. Because I forgot to open the gate. No more. Turn your airflow into cash flow.
So, ever been in that situation where your industrial gear, it just struggles with the really tough abrasive stuff you're processing?
Oh, absolutely.
Constantly fighting wear and tear. It feels like the material itself is working against your machine.
Yeah, every single component, right. From tiny valves up to the big ducts. It's all under attack.
Right.
And the costs, maintenance, downtime, you just pile up.
Exactly. So how do you actually build something that lasts? Something that can stand up to that kind of erosion long term?
Well, that's a huge challenge across so many industries. And it's why today we're really going to dig into industrial ventilation and dust collection systems,
Okay.
specifically focusing on maybe the toughest scenario, highly abrasive environments. We're going to unpack what we can learn from a really interesting case study
Right.
about what it takes for a system, particularly those critical moving parts, like the blast gates,
Yeah.
to actually last and keep working well when you've got literally grinding material flowing through them.
Okay, so our mission today then is to explore this article from the Ecogate blog. It's called Ecogate Smart Gates, Proven Longevity in Highly Abrasive Environments. We're going to look at how one company tackled this challenge head on. And, more importantly, what lessons that holds for your operations if you're facing similar grit, similar wear.
Yeah, it's not just about collecting dust, is it? It's about engineering things properly for the long haul, designing for durability, for real value over, well, years, maybe even decades.
So let's start there. To really get a handle on this, what does highly abrasive actually mean inside a dust collection system? Like for someone running a plant, what are the day-to-day headaches?
Well, the key thing to understand about highly abrasive, it's not just about dust being fine. We're talking about materials that inherently cause a lot of friction, impact, erosion. Basically on any surface they touch as they move through the ducts.
Okay.
Imagine tiny, tiny shards of glass or little metal filings, sharp mineral fibers. They're just floating along. They're like microscopic projectiles, constantly bombarding the inside of the system.
Right, like a sandblaster effect almost.
Exactly. And this relentless attack just speeds up the wear on everything. The ductwork itself, sure, but especially the internal parts of gates, valves, you name it.
And a practical result.
It means you're constantly doing maintenance, dealing with costly downtime, and ultimately, your operational costs are just higher. So when you're dealing with that kind of constant grinding, system durability isn't just, a nice bonus. It's absolutely essential to keep things running, to stay profitable, frankly.
Yeah.
It really pushes engineers to think much more carefully about material science, about the design itself. You can't just use standard off-the-shelf stuff.
I can picture plant managers listening and just nodding right now. If you're working with wood, metal, composites, maybe even tricky insulation materials, you know this fight against wear. You need parts that can actually take the punishment day after day.
Totally.
So the article then gives us this fantastic real-world example. It highlights a specific facility that really put an Ecogate system through its paces under these exact conditions.
Right.
It's one thing to talk about durability in theory, but proving it over the long term, that's different.
Precisely. The article points to the Owens Corning facility over in the Czech Republic.
Yeah.
Specifically, their Pittsburgh Corning division.
Okay.
They produce this insulation called FAMGLS HLB 1000. It meets ASTM standards, that's the American Society for Testing and Materials, a big benchmark for quality.
Right.
And here's the critical part. Making this stuff involves handling highly abrasive glass particles and fibers. Just imagine that.
Yeah.
It's a truly extreme, really challenging environment for any ventilation system.
And the kicker is, this facility, they've been using an Ecogate on-demand dust collection system for how long?
Get this, over a decade.
Wow.
14 years, continuous, reliable operation in these incredibly harsh conditions, dealing with some of the most abrasive stuff you can think of.
14 years. That's seriously impressive. What does that kind of longevity actually mean for a company like Owens Corning, practically speaking?
Well, first off, after all that time, they're still really happy with the system's performance.
Yeah.
But the real proof, I think,
Yeah.
is that after 14 years, they're not just keeping the old system limping along, they're actually placing an order for another Ecogate system because they're expanding.
Ah, okay. That says a lot.
It really does.
Yeah.
It's not just about survival in a tough spot. It's about the system performing so well that it's the go-to choice for their growth. That speaks volumes about the long-term value, the reliability, the ROI they've seen.
Right. Less unexpected downtime, lower maintenance costs over the years.
Exactly. Consistent performance. It all feeds right into their bottom line.
Okay, so what was the key? The article mentions a specific type of gate design being crucial. What did Owens Corning find out about different gate types in this abrasive environment? Sounds like they learned something along the way.
Yeah, that's a really important part of the story. Initially, the facility tried using Ecogate's butterfly gates.
Okay.
But, well, as you might guess, with highly abrasive glass dust, those gates started showing excessive wear over time.
Makes sense.
It really demonstrates a key engineering point. Not every solution fits every problem, especially with aggressive materials like this. It shows how quickly the wrong design, even a well-made one, can suffer if it's not specifically built for that challenge.
So it wasn't just about beefing up the butterfly design, it was a different approach entirely.
Exactly. They switch over to Ecogate rotating blade gates.
Okay, rotating blade gates. What makes these so tough? Why could they handle this environment for so long?
Well, the article breaks down what they learned over those 14 years, and it really highlights the durability. First, hardly any gate failures.
Really?
Yeah. Out of all the rotating blade gates they installed, only one stopped working. And the reason? It was located in a spot with excessive air turbulence in the duct. So an installation issue, not a gate flaw itself.
The interesting detail.
Very. And second, all the other gates, still running fine, continuously operating, fully functional.
Okay.
And here's the really telling contrast. The heavy-duty ductwork around these gates, that had to be replaced multiple times over the same period.
Wait, the ducts wore out faster than the gates.
Significantly faster. We're talking heavy-duty ducts designed for abrasive stuff, and the rotating blade gates outlasted them.
Wow.
And these gates, the rotating blade ones, they're pretty versatile too. Come in sizes from 4 inches up to 26 inches, and you can get them zinc-plated or in stainless steel, depending on what you need for this specific job.
That point about the gates outlasting the heavy-duty ducts, that really paints a picture. Can you give us a rough idea, like how long would you expect that kind of ductwork to last in such an environment compared to the 14 years the dates achieved?
Well, typically, in really abrasive situations like this one, even specialized heavy-duty steel ducting might only last, say, 5 to 7 years, sometimes even less, depending on exactly what's flowing through it and how fast.
Okay.
So the fact that these Ecogate rotating blade gates have kept going for 14 years, right through multiple cycles of duct replacement, it just underlines how well engineered they are for endurance. It means that the critical control point, the gate itself, is actually far more reliable and needs less attention than the static pipes around it.
That definitely highlights their durability. But as you mentioned, the article brings up that one gate failure due to turbulence. That seems like a critical lesson too. Even the best tech needs correct implementation.
Absolutely. It underscores the importance of adherence to best practices during installation.
So what are those best practices for placing these gates? And why are they so important, especially when you've got abrasive dust flying around?
The article is pretty specific here. It recommends installing gates at least 3 duct diameters away from things like hoods, elbows, or branches in the ductwork.
3 duct diameters. Why that specific distance?
It's all about preventing air turbulence.
Right
at the inlet and the outlet of the gate. If the air is smooth and laminar, the dust flows through cleanly.
Okay.
But if you put a gate too close to a bend or a branch, the air gets chaotic, turbulent. Think of swirls and eddies. That turbulent air makes the abrasive particles slam into the gate components harder and more often, dramatically increasing wear. It can also cause dust to build up inside the gate mechanism, stopping it from working properly.
So like hitting potholes instead of driving on a smooth road.
That's a good analogy, yeah.
Yeah.
It just beats everything up much faster.
Yeah.
Following that simple placement rule helps ensure a smoother flow and protects the gate.
That's really practical advice for anyone listening. Simple installation rules can make a huge difference to the lifespan and efficiency of the whole system. It's not just the component, but how you use it.
Exactly. System thinking.
Now, this kind of performance, this 14-year track record, it doesn't just happen by accident, right? It clearly points to some serious design work and testing beforehand. How does Ecogate make sure these gates are ready for such extreme conditions?
You're right. It's absolutely intentional. The article talks about their internal testing protocol, and it's pretty demanding. Before a new gate model gets the green light,
Yeah,
it has to go through 1 million open-close cycles.
1 million. That sounds like a lot. Can you put that number into perspective? What does a million cycles actually look like in terms of nonstop testing?
Okay, yeah, let's break that down. Take a standard 5-inch gate. It takes about, say, 5 seconds to open and close completely. That's one cycle.
Right.
Multiply that 5 seconds by 1 million cycles. You get 5 million seconds of continuous testing.
5 million seconds. How long is that?
That works out to roughly 2 months of the gate just opening and closing nonstop.
Yeah.
247. It's simulating years and years of hard industrial use in a compressed time frame.
Wow, 2 months solid.
Yeah. And the standard is tough. After those million cycles, the gate has to be fully functional. Sure, there might be some expected, predictable mechanical wear, but it has to work properly.
And if it doesn't?
If any prototype fails that test, it goes straight back to engineering. Redesign, rebuild, retest until it passes. It really shows their commitment to making sure these things are durable before they ever get shipped out.
That makes sense. True reliability comes from pushing things to the limit in the lab first.
It's exactly engineering confidence.
So it really isn't just about selling you a gate. It's about giving you that confidence, that peace of mind, knowing this piece of equipment has been seriously stress tested before it lands in your facility. That avoids a lot of potential headaches later.
That pre-market validation is crucial.
So wrapping up our deep dive today, we've seen how really solid engineering combined with smart installation practices can lead to pretty incredible longevity, even when facing really harsh industrial conditions.
Yeah.
Those Ecogate rotating blade gates, proven over 14 years at that Owens Corning FOMG last plant, and backed up by that intense million-cycle testing. They're a powerful example of engineering for the long haul.
Absolutely. And if you connect that to the bigger picture, the takeaway from the article is pretty clear. If your facility is dealing with abrasive materials, really understanding the challenges and investing in technology that's proven to handle them can dramatically extend your dust collection system's life.
Which means better efficiency.
Better efficiency, better reliability, less unplanned downtime, which ultimately saves money and boosts productivity. It really impacts the bottom line and how you plan for the future.
So here's maybe a final thought for you, our listener, to mull over. In this industrial world where fighting wear and tear often feels like a losing battle, what could it really mean for your own long-term costs, your efficiency, if those critical components in your system, like smart blast gates, could actually deliver proven longevity? Not just as a slogan, but as a demonstrated reality, like we saw with that decade-plus performance. What doors would that open for your facility's uptime, your maintenance budget, your whole operational strategy?